Good afternoon, everybody. My name is Salifa Shrestha. I am from section 37A. I am a BSc Honors Computing student. Today, I am going to present my data science coursework where I analyze property investment opportunities across Norfolk and Suffolk using real UK government data sets. The aim of my project was to answer a simple but practical question. If someone wanted to buy a house in either Norfolk or Suffolk, which towns would offer the best overall balance of affordability, internet connectivity, safety, and education? Instead of relying on opinions, I used data to answer that question. To complete to complete this project, I followed the full data science process from collecting raw data sets, cleaning and integrating them, uh, analyzing the data, and building a relational database, and finally building a recommendation system. The objective of this project was to for this analysis, I considered four different factors. The first was house price because affordability is one of the most biggest consideration when buying a property. The second was broadband speed since fast and reliable internet is essential for both work and everyday life. The third factor was crime rate, which represents how safe an area is. Finally, I included school performance because good schools are important quality of life for factors and families. One of the biggest challenges was that every organization came from a different data set. There were each one described locations differently. Some used postcodes, some used district, and some used LSOA. School dataset used parliamentary constituencies. So before I could analyze anything, first and foremost, I needed to make sure all of these dataset were compatible. So the next step was data collection. I collected four official datasets from the UK government sources. Here you can see in my CVS file, and I merged them. They were like many of the data sets, but so I merged them into different files. And the first data set was HM Land Registry Price Paid, which contains information about residential property sales. The second data set came from Ofcom, providing broadband performance information such as average download speed, upload speed, minimum, maximum, and median speed. The third data set was downloaded from police.uk, containing crime incidents reported across different locations. Finally, I used Department for Education Key, Stage 4, and data to analyze school performance. Although these datasets were publicly available, they had different formats and different geographical references, which meant a significant amount of pre-processing needed to be done. So the next step was data cleaning. As you can see in my screen, there were four parts the data were divided into. The part 5 is linear regression, that is linear modeling. So the data sets were divided into four parts. Part 1 included house price EDA. Part 2 included broadband speed exploratory data analysis, and the third part included crime data set, and the fourth part included school data, and the fifth part I told you already. So the first thing I did was I standardized every postcode by removing spaces and converting everything into uppercase. I created a postcode lookup table using the house price dataset because it already contained district and county information. During that lookup table, I linked broadband and crime datasets to the correct district. For the crime dataset, I discovered a I for the crime data set, I also discovered district names, and extracted from LOC using field regulation expressions. While testing my database, I also discovered a mistake in my broadband cleaning script. Initially, one of the The mistake was only the average download speed had been saved, while maximum and minimum, medium, and upload speed columns were missing. After checking my code, I found the issue, corrected the script, and built the database uh, so that the broadband information was included correctly. Database design. After this, I went to database design. So in the database design, I first and foremostly made sure that the data were in 3NF form, and because 3NF form helps to reduce redundancy and improve consistency. Instead of repeating county and district name throughout every table, I separated them into for lookup tables and connected everything using foreign keys. The database contains table for counties, district, postcode. I will show you in my SQLite. So the database consists of tables for counties, district, postcode, house sales, broadband speed, crime incident, school, and school performance. To verify that database, if the database work correctly, I you can also see it in here, and I will also like to show you data. These are the data, and yeah, and to verify the database, if the database worked correctly, I executed SQL join queries that combined multiple tables and successfully calculated average house price by district. You can see it in the code. And the next step was data analysis. I told you already my data were divided into four parts, and each part consists of different EDA, and I have saved them into an output folder. You can see in the document folder, you can see there are different type of output folder. So I would like to show you one EDA. So let's go to broadband outputs, and I will show you the box plot of the broadband. So you can see the average download speed by district or town. You can see in the box plot. In this way, I have done EDA, and I also performed several linear regression to analyze and investigate relationship between these variables. I created box plot, bar charts, line charts, scatter plot to compare the house prices, broadband performance, crime rate, and school performance. You can see here. This is the rather chart also. In the rather chart, you can also see here, and some relationships were statistically significant while others were not. Uh, this showed that this showed that ton of the town had ton of the town had perform well in one category but not necessarily in another. For example, lower house prices did not always correspond with higher crime rates, and better broadband did not always mean more expensive housing. So, I finally built a recommendation system basis on this analysis. So, the final stage of my project was building this, and each town received a score of between 0 and 10 using mean max normalization. You can see it in this code. I used normalization and created a score of town 0 to 10 for the house prices and crime and lower. Okay. For house prices and crime, lower values produces higher scores, but because lower is considered the better. For the broadband speed and school performance, high values received high scorers. I will show you. Based on this analysis, the top three locations were based on this analysis, the top three locations were Broadland, Great Yarmouth, Ipswich. and each town had different strength. Broadland performed particularly well for safety and school. Great Yarmouth had the most affordable housing, you can see in the numbers, and Ipswich achieved the highest broadband speed. Rather than selecting the winner based on a single factor, the combined scoring produced a much more and balanced recommendation. On one limitation of my project was that only six towns had complete information across all four datasets due to differences in how school locations were recorded. Instead of forcing incorrect matches, I clearly documented this limitation in my report. So I will show you the top 10 towns livability top town score in this bar graph. You can see there is Borland, Great Yarmouth, Ipswich. These are the top three towns, and the others were South Norfolk, North Norfolk, and West Suffolk. I also created a livability score. You can see here. The best was the Broadland, and the ethics were throughout this project. I only used the official UK government data set. I did not use another data set. Though personal information was collected or processed, crime data was already anonymous, and any missing or suppressed school data was treated as missing rather than estimated. So, in conclusion, the project demonstrates the complete data science workflow, starting with raw government dataset. I cleaned and integrated the data, designed normalized database, performed statistically analysis and visualization, and finally developed a recommendation system that identifies the most suitable towns for property investment in Norfolk and Suffolk. Thank you so much for listening.